In this lesson, we're going to examine some quadratic word problems. Here, we're going to take some information we're given in questions, and we're going to try and establish an equation that can be solved. If you can, you want an equation with only one variable, though in some situations you start off with two, and you need to substitute one equation into another to get rid of that second variable. Remember, solving quadratics, standard form equal to 0, and if you can, factor, and if you can't, well, you're stuck with the quadratic formula, then that's what you got to do. So, I'd like to see good problem-solving techniques, which means you need some let statements, the equation, the math, and therefore at the end if you can. Okay, so let's start with a nice simple one. The sum of the squares of two consecutive integers is 113. Okay, if things are consecutive, that means they're in order. So if I make x my first integer, the next one after that is going to be one larger than the previous number. For example, 12 and 13. To get from 12 to 13, you just add 1. So my let statements are x and x plus 1. Now I want to take the sum, which means I want to add the squares, which means I want to square things. So I'm going to take the first one and square it, and then add that to the second one squared, and I know it comes out to 113. There's my equation. One variable, just the letter x, which means it's solvable the way it is. But in order to solve it, I need it equal to 0 and standard form first. So let's get rid of our brackets. Write them out twice. I want to make it equal to 0, so I'm going to bring the 113 over. I'm going to do some FOIL. I'm going to collect my like terms. So 2x squared plus 2x minus 112 now. And that's ready to be solved. Standard form equal to 0. Let's try factoring. By common factor, I end up with a simple trinomial. Can I think of numbers that add to 1 and multiply to 56? I have numbers that do that for sure. Positive 8 and negative 7. And that's my factors. To solve it, I've got to write down what are the answers. So negative 8 and positive 7. So my answer at the end has to answer my question. What are the integers? The integers are, now I've got two situations here. X could be negative 8, which would mean that x plus 1 would be negative 8 plus 1, which is negative 7. Or x could be 7, in which case 7 plus 1 would make 8. So there's actually two sets of answers that make this work. And the reason why that is when I square things, negative 8 is the same as positive 8 squared. So the negative signs disappear when I square those two things. Yeah, that's a nice moral point. Let's try the next one. Two integers differ by 8, and the sum of their squares is 130. So my let statements, x is my first integer, and I know they differ by 8, which means they're 8 digits apart. So I have a choice here. I can say either x plus 8, or I can say x minus 8. It doesn't make a difference which. You'll get the same answer either way. And I see the sum of their squares again. So this is kind of like the last one. X squared plus x plus 8 squared is 130. So you guys should be able to solve it from here. The same procedure. Our brackets by squaring them, write them twice, make it equal 0 so we can solve it, FOIL it, collect our like terms, so 2x squared, 16x, and 66. Try factoring if we can, in this case we can, and just as a hint, an idea, if it tells you in the question that some things are integers or whole numbers or things like that, then they have to be factorable. Because when I factor things, I always end up with whole numbers. We'll try some man. We got an add to 8 and multiply to 33. So x plus 11, x minus 8. My answers are either negative 11 or 8. Which when I go to my therefore means the integers are are, well, if x is negative 11, negative 11 plus 8 would make negative 3. Or if x was 8, 8 plus 8 makes, oops, 16. Oh, you know what? I wrote down the wrong number here. This is an 8. This is a 3. I was thinking ahead of the answer. Sorry, my fault. 3. Makes way more sense. Okay, so x is either 3 or 3 plus 8, 11. And just another pointer, usually when you get your answers, they're going to be the same numbers, just opposite signs. Like this one and the previous one. And those are sort of numerical kinds of questions. The third one, we're going to look at a shape. So we have a rectangle. We're told it's 4 meters longer than it's wide. Its area is 192. So if we draw something out, I count that as a let statement, especially if I put the numbers into it. So it's 4 meters longer than wide. So if I say x is my width, 4 meters longer than that, it's going to be x plus 4. I know the area of a rectangle is always length times width. I know my area is 192, and my length and width are x, and x plus 4. It's ready to be solved. If I put it in standard form, it'll make it equal to 0. So let's do that. This time we're going to multiply our bracket out. X squared plus 4x. I'm going to bring the 192 over, make it equal to 0. I'm going to try factoring this if I can. So I need to multiply to 192, negative 192, add to 4. Think of numbers that do that. Again, yes, there are numbers that do that. The numbers that work would be 16 and 12. So 16 and 12. Our answers this time are negative 16 and 12. Now in this case, I have an answer that doesn't work. It doesn't make practical sense. I can't have a width of negative 16. We call that inadmissible. Mathematically, it's a solution, but it's not a practical solution. So, the rectangle is, well, x has to be 12, so 12 meters by 12 plus 4 makes 16. And notice again, it's the same number, it's just we got rid of the sign, right? Usually that's the way these quadratic questions work out. Okay, let's try the next one. Slightly more challenging this time. A right triangle has a hypotenuse of 10 meters. Oh, too far. So we can draw that out. A right triangle. Hypotenuse, 10 meters. If one of the sides is 2 meters longer than the other, find the dimensions of the triangle. So if one's 2 meters longer than the other, so if I make one of them x, the other one's got to be 2 meters longer than that, x plus 2. Now, the idea in this question is you have to remember that we can use Pythagoras for sides of right angle triangles. In particular, if I use a squared plus b squared equals c squared, where c is our hypotenuse, then my other two sides have to be the a and the b. There's an equation that's going to produce a quadratic. It's got some x squared in it. It also kind of looks like the sum of the squares of two digits, right? It looks basically the same idea. So let's treat it the same way. Write out our brackets, bring our number over, and then FOIL. Okay, 10 squared we'll write down as 100, might as well. We'll collect our like terms, and then we'll try factoring. Again, it has a common factor, so take it out. Think of things that add to 2 and multiply to 48, and sure enough, we can do that. X plus 8, x minus 6. We have two answers. Either x is negative 8, which, well, that's not possible, so inadmissible, or x is 6. If x is 6, what does that tell us about the other side? Well, 6 plus 2 has to be 8. So the other sides are 2 meters, oh not 2, sorry, 6 meters, and 8 meters. Okay. It's a shape question, but it's a shape question that kind of looks like the sum of the squares of two digits. Basically the same idea. Let's go one more. Money problems. Money problems are something we spent a lot of time on in grade 10. We did them in a variety of ways. We actually did them in this unit 2 when we talked about optimal values. So reminders, our revenue is always equal to the price times the number of sales. So in this case, we're told we have a price of $2, but we want to change it. We want it to go up by 10 cents every time I change the price. Reminder, X state. That statement X is always your number of changes. Okay. The $2 we're charging might not be enough. Maybe you have to raise that price 4 times or 5 times, or maybe you have to lower it. I'm not really sure yet. Our initial value, we have 25,000 passengers, but every time I change the price, I'm going to lose 500. And my X is the number of times I change that price. This time I'm asked to figure out the fare, the price, that would generate a profit of 59,450. So that's going to go in for our revenue over here. How much money I need to earn. Here's my equation. I want to solve it. So standard form equal to 0. So on the right side I'm going to FOIL. So 2 times 25,000 is 50,000. 2 times 500, 1,000x. We're just doing regular old FOIL. 0.1 times 25,000 is 2,500. And 0.1 times 500 is minus 50x squared. I also want to make it equal 0, so I need to bring the 59,000 over to the other side. I put it at the end over here. Okay, what do I get? If I put them in the right order and I collect my like terms, negative 50x squared plus 1,500x minus 9,450. Okay, standard form equal to 0, ready to be solved. These are big numbers. So let's try common factoring first. Let's take that 50 out. In fact, let's take the negative 50 out, so my squared term becomes a positive. Kind of what we want, right? 1,500 divided by negative 50 will give us negative 30. And negative 9,450 divided by a negative makes a positive 27. Can we think of things that multiply to 27 and add to 30? Sorry there, I missed a digit. I put on my calculator, not 27. That would not make any sense. 189. Sorry, 9,450 divided by 50. Okay, big numbers this time. Think of things that multiply to 189. Now, these are big numbers, so give yourselves, I don't know, 10 seconds. Try some combinations. What can I divide 189 by? I can try 3 and, what's that, 3 and 63. Well, that doesn't work. 4, 5, 6, and so on. Now, there are numbers. I'll tell you what they are right now. So x minus 9 and x minus 21. Okay, that does work. Multiplies the 189, adds 30. So our answers are either 9 or 21. Now, when it comes to money questions, both answers are admissible. You can either change your price a lot, or you can change your price a little. The more you change your price, the higher it gets, the less customers you have, but you'll still make the amount you want. And if you only change a little, you have a low price, but lots of customers. The question asks us our price. Now the price came from the initial equation, the left-hand side. It was 2 plus 0.1x, where x is our number of changes. These are our number of changes. So our new price, we have two options. It could be 2 plus 0.1 times 9, so in other words, $2.90, or 2 plus 0.1 times 21, which comes out to, what's it, 4.10. Okay, so therefore, to make 59,450 charge either, as both options are allowed, 290 or 410. Okay, there's our word problems. Just reminders of some things. Try the homework questions. There's only 5 of them there. And make sure you can do a little bit of everything, a little bit of shapes, a little bit of numerical, a little bit of profit or money questions. They are repetitive from grade 10, but we need to know how to do this again this year.